Hello there, this is Daniel from Two Chefs and welcome to this new video. So now we're going to build our first Locomotion asset. So I'm gonna open the Atoms UI, go in the Locomotion tab, and I'm gonna call this one Locomotion. Then I'm gonna right click in the viewport, or you can even press on this button, which basically just open the animation clips dialog. And I'm gonna drag and drop the my main idle loco, the main jog, and the main walk. Like this. Also, I'm gonna change the font multiplier to 2 so I can see the text here. So as you can see, as soon as I drag and drop the clips in the viewport, Atoms place them in a specific location. Basically, Atoms evaluates their position by calculating the average linear and angular velocities for the clips. So in this case, basically for the main walk, you would go and get the clip, get the frame range, so 36 and 70, find the average linear and angular velocity in this frame range, and then use those values for the coordinates. So basically, Atoms placed now the walk at 137 and 0, which means that the angular velocity is 0, the clip is just going straight. And then the average velocity is 137. I'm gonna change this one to 130 because again, you can go in here and tweak the positions to round them up if you want. The idle is at 0, 0 because it doesn't turn and it doesn't move. And then the jog was moving at 277, and then I changed it to 275. And again, even the jog is not turning. So I'm gonna save this asset. I'm gonna go in my scene. I'm gonna create a new agent group. And I'm gonna just build a quick setup. So I'm gonna attach a grid layout and a Locomotion asset. So the Locomotion, I'm gonna set the Locomotion one. Let me change the draw type to skin. And also I want to show the target linear velocity metadata. You can actually, open the menu here and find it. So target, where is it? Target linear velocity. I've already added it, and basically this value is at 0. There's also target angular velocity here. Their default value is 0, so that's why we see here 0, although we're not setting it in any way. And basically, the target linear velocity and the target angular velocity are the values that Atoms is using for finding the clips to play. So in our case, we said that both values are 0. So in our graph at 0, 0, we have my main idle loco, so this is the clip that is being played. If we change the value to 130, for instance, we would be playing the main walk. So I'm gonna click the bug. Here we see the weight. So we have the my main idle loco at 1. Let's change that metadata to another value. So I'm gonna attach another metadata module. I'm gonna change this to double, and then the value is the target linear velocity. If I set this to 130, now as you can see, the agent is walking. If I change it to 275, the agent is jogging. And of course, we can animate this value. So let's start at 0. Then let's set this one at 130 over there, and at 275 over here. So the agent basically will start walking and then jogging. One thing that is quite useful, instead of just seeing the values of the clips here, is also using the debugger. So we can go under the Locomotion tab. Here again, we see the same graph that we had in the Atoms UI. Let me change the scale, the font multiplier here as well. Or actually, we can even hide these at the moment because we don't really need them. And in here, when you play, you'll see a few points moving in the graph. You see here, there's like a red circle and a green circle. The red circle is the actual position that we're providing at every frame. So in this case, the target linear velocity is at 48.6, and that is the position of the red circle. While the green circle is actually the position that is being used by Atoms for playing the clips. They differ because of some settings on the Locomotion module. Basically, as you can see here, there are some settings that are also shared with other modules like the state machine and the clip reader. But in the case of the Locomotion, we have more settings. For instance, we have this linear average num frames, and angular average num frames. These two values are basically are calculated, so they're used for calculating this green circle here. So basically, by passing 5, you're telling Atoms to calculate the actual position of the current position in the graph by using the average of the last 5 values. You could say 10, and the animation will be even smoother. While the max acceleration for both the linear and the angular accelerations, they are used as a maximum variation of either the linear or the angular values per frame. So we're saying basically at the moment don't change by more than 45 per frame. Okay, all of these values are useful for smoothing out the simulation. For instance, if you are in a very dense area, if you set these values to 1, 1 and a very large value here, you might see a lot of jittering, the agents trying to play a clip and then playing another and so on. This is because, of course, the inputs, they can vary during the simulation. So by providing some values for blending out, for smoothing the input position, then you're actually creating a better simulation. There's also another value here, which is like the force unsync clip. This value, when you check it, you're telling Atoms that if any unsync clip matches the variation of both the direction and the linear velocity at this frame, then basically Atoms is allowed to play an unsync clip. If this is unchecked, the unsync clip will be totally ignored in this simulation and they won't be played. Okay, now let's build a 2D locomotion system. Okay, so going back to the locomotion asset, I'm gonna import the two left and right 45. I'm gonna click on the import button so I can import them at the same time. Otherwise, if you drag and drop, you can just import one clip at a time. I'm gonna change the X value for both to 130. And actually, first, before that, you notice that these clips are not symmetrical, although we would expect them to be. And this is because the frame range that we set up earlier is different. You remember when we mirrored the clip and then we set up the frame range, those frame ranges were different. So that's why they don't have exactly the same value. You can, of course, come here and tweak the graph by hand, which is what I'm going to do now. Of course, this is not something that you might want to do all the time, but let's do it for this example. Just to build like a very nice graph. And so, yeah, basically this is it. Another thing that I forgot to mention earlier is that when you place clips into the graph, Atoms does an extra step other than just calculating the average linear and angular velocities. What it does basically, it gets the clip with the minimum frame range inside the graph, and then normalizes all the velocities using that frame range. And this, so basically we can get like a better result later. If by any case you want to see, this is to say that depending on when you import the clip in the graph, you might be placed in a different location. Maybe, like not so far off, but, like it would still be in a different place. It wouldn't have the same X and Y value. So for instance, if you want to see those values where basically the clips would be considering all the clips that are in the graph, you can always press the relay out button and the clips would be placed again. And so as you can see here, the values are a bit different than before. I'm just gonna go back to the graph that I prepared nicely. So we're gonna use this one. Then I want also to import the two unsync clips that we prepared earlier. So this one, it says that it has like some linear velocity, but I don't want any because this is an idle clip. And also I'm gonna change the Y value to 90. This one is a work turn 180. So I'm gonna change the 130 as to be the linear velocity of the work, and the 180 to be the angular velocity. Both of them are unsync. I'm gonna check this, and you see here the points turn square, and then also these triangles, the edges of these triangles became orange, and this is to let you know that there is an unsync clip in this triangle. I'm gonna change the blend frames to 5 and 5. I'm gonna leave the weight frames to 0 because we don't really care for this example. Okay, so that's ready. I'm gonna go back to my scene. Here I've already created a locator that moves into the scene. I have assigned my locomotion, so this basically is the scene that we had before. now what we can do is that we can create a follow target, and this is gonna show you how you can drive the locomotion with some behavior modules. So for instance, if I drag and drop the translation of the locator on the goal of the follow target, now I press play, the agent is running towards the locator because the locator is pretty far. There are a lot of attributes here, but at the moment let's just focus on the max linear velocity. I'm gonna set it to 130 so that the agent never go faster than the linear velocity that we have for the walk. So the agent is just gonna walk at maximum, okay? And then I'm gonna open the debugger. I want to refresh it. So now I can press play, and we'll see that the walk left is gonna be played. So you see there the weight for both the walk and the walk left. And so basically this is how you can debug and you know, and see if your clips are working properly. You can just attach a follow target, move it around, make the agent turn, and so on. So here, as you can see, we have a yellow circle that is brand new that we've never seen before. The yellow circle is the value that we use for unsync clips, that basically Atomos uses for selecting an unsync clip if any matches. In this case, we don't have any match, so at the moment we're just playing the walk left 45 and the walk. So let's go back here. Let's remove the follow target. Another thing that we can do, for instance, if you have a formation, is we can drive the formation with both the target linear velocity. So target linear velocity, and then also we can add the target. Sorry, this is a double target frame angular velocity. So this is the value that we use for picking the right unsync clip. It's not actually the target angular velocity. That is the target angular velocity is used for the standard clips. So depending on the value that you provide there, you're able to rotate your agents and pick unsync clips. So let's clear the selection here. Let's say, for instance, I want to, when I come to here, I want the agent to turn 90 degrees. Set another keyframe. Set this one to 0. And you have to be careful and set this value back to 0 because you don't want your agents to keep turning 90 degrees, right? So if I press play now, my agents are gonna turn left. You have to be careful when you, for instance, if you want to want your agents to play another unsync clip, that all your agents are finished actually playing an unsync clip. I'll show you why. So if I, for instance, here, I set, actually this one probably is a bit too early. Let's go at frame here, something like this. Maybe this is still good. Let's set it to 90. So if I play that and play that again, you see just some agents turn left at this time. This is because the other agents were still playing the other unsync clip, so they didn't have the time to finish to play that clip. And then when this value changed, they were still playing that clip, so they didn't really, they couldn't select the clip again. So you have to wait until that clip finishes playing. For instance, we could, when you see this kind of stuff happening, you can really open the debugger. We can actually display the group ID for these agents, the group ID. So for some of these agents, so I think actually it was 7. Let me refresh this one. So 7. So you see here, no, actually, let me go back, sorry. So now we're playing, you see here now it's picking the, let me go back. So we saw for a second, for a split second, let me go frame by frame. Okay, now the yellow circle is here, was here, so Atomos picked the idle left 90, and then it started playing the idle left 90. After a while, we'll see it here kicking in. You see there, it's there appearing. So now it's playing, still playing. Also, you see that because this vertex is still, this point is still red. Still playing, still playing, still playing. Now we reach this point. It's actually blending out, so it wasn't far off. But now when it's 90, when this go back to 90, it's still playing. There's no time for it to pick up again the left 90 and then play it again. So it's just gonna keep playing, and now it's just playing the idle loco. So to fix this, of course, you can just select these frames, move them a bit here, and give it just the time for it to finish to play the unsync clip. That guy over there still needed a bit more time. Okay, so now they're all there, and then what we can do, for instance, we could say, now I want these agents to start working. So let's go here. Actually, let's go, yes, somewhere around here. Say that value there, and then we can say 130. And then actually, you know what, we could even make them stop again. And once they stop, we can say turn again 180 degrees. Sorry, not 180, let's just do the 90. 90 degrees. Then another turning. They start working, stop. Actually, I need to leave some more frames in there. And actually, let me make this one even a bit bigger. So they have a bit more frames. And let me move this one here. And let me change this value to 350 or something. Oh, no, sorry, not that one. It's this one. Okay, so they have a bit more time. Turn again. Start working. It's still too early. Okay, something like this. And here probably gonna leave a bit more frames so that we can see all the simulation. Okay, so you might be wondering, okay, but like what if I want the agents to move a bit further, faster? I don't want them to wait until until all of them are in the same direction. Maybe the director wants this shot to be a bit faster. It's quite easy to fix actually. The only thing that you need to change is the start frame for the agent. So at the moment they're all random because the start frame here is set to -1. But if you make the start frame to be a bit closer for each one of the agents, so you can randomize them and provide like a value between 0 and 20, then the variation would just be around 20 frames. You can make them shorter by changing the start frame to maybe 0, 10, and so on. Of course, if the start frame is the same or very close, the animation of the agents will look quite the same. So you might want to tweak that value until you reach the best result that you want to get. Okay, this is all for this video. Thanks for watching.